Business Statistics Unit number 5. So this week we're going to be looking at the practice. This week is very interesting because first of all, you're going to do half of it with me, and the other half you're going to do it on your own. Okay, hopefully it's not that difficult. Of course, if you are able to follow with me the first one, you should be able to do the second one. Of course, there's some things that you have to think a little bit, so that is a challenge in there, but you should be fine, so don't worry much about it. It's very simple. Okay, so first of all, we're going to be looking at this one. We're going to be start working with the cost of traffic. So let's go to the cost of traffic instructions. So in this case, we have that we all have been stopped by traffic at times. We had to sit there for a while in the freeway, in the traffic, and well, if you have someone with you, have music, it's a good experience. But if not, that means that you're gonna be stuck in there for a while, and that costs money to the society. Okay, so in this case, we're gonna be looking at money. So we're gonna be looking at data presented in a table in the cost of traffic. Okay, so that is what is important. We have some larger groups as regions, and we have some cities in there. Okay, so in this case, we look at it. First of all, we have it's gonna be well, it looks like a multivariate data, but it's not. It is not a bivariate, and this one is just one variable because we're gonna use only these numbers as variable. Okay, so anyways, we have here by the region, we have the elements of it: region, city, and the cost of traffic. Okay, fair enough. Then we're gonna be doing all the cities. Okay, fair enough. Good. So now let's go to the basic instructions. So first of all, insert the data in a table. Now here, before I start to insert the data in a table, we have to understand that sometimes we need to clean the data, because if we don't clean the data, it's hard to be working with it. So in this case, for example, if I use some of the functions that I have taught you before, for example, the shift control down or shift control arrow down here, because I have some because I have some missing information that make some trouble when I'm selecting the data. So let's try to make it cleaner first. Okay, so in this case, for example, if I go shift control down, shift control down, shift control down, that's great. Shift control down, but then whoops, you realize it goes all the way to that number of cell, and that doesn't work for me at all. No, because in the end, is too much data. So for that same reason, I need to clear it. So let's go first to the first, let's go, don't do it again, just watch and then you do, otherwise you do the same mistakes that I'm purposely doing. So in this case, the first thing that we have to look at is filling that information that is missing. Okay, so first of all, we have the northeastern cities. So here I'm gonna teach you one shortcut, but this is very useful because of copying the formulas. Excel, I'm sure that you already have. You can, let's say for example, if I have on the cell, and this is, you don't have to do this, just watch what I'm gonna explain and then you do it. Okay, so let's say for example that I have equals this row plus this row. Okay, so I have 1956 and I want to copy that, but if I just copy that, then there might be chances that sometimes I just copy, or sometimes it copies the formula. You have to see C15 plus C16. Yes, it's going the next plus the next one. Okay, so in this case I can do that and I can copy the formula, or I can also drag it. Okay, so this is different because in this one is just also consecutively. But anyways, so we're gonna be using that whenever we are on we're gonna be on a cell. We go the plus. I think we have done this before, but anyways, in this case we want just to copy northeastern cities. So in order for us, instead of control B, control C, we're just gonna go like that. Okay, and then the same thing. There's an autofill function, but sometimes it's not. Sometimes it's good, sometimes it completes as well, but sometimes it doesn't. Like for example, in this case, it did very well. Okay, so now let's continue doing it. Okay. See, sometimes it works, sometimes it doesn't. So, and then let's fill the data. Okay. So we have there already a clean table, and that's well, a clean data. Sometimes we need to clean the data before start to working with it. If there's any mistakes, if there's any something wrong, we have to adjust it before we start. Okay. So in this case, I have insert the data in a table with empty values. I already did it. Done. And then insert the table. Now I can use a shortcut. Control Shift down, Control Shift to the right. Then I go to remember as we did the last time in insert, and we're going to insert a table. Okay, very good. So in this case, I go one more time. I go to insert. Remember the table is here. Okay, one more time in case you don't remember from last week. Sometimes it happens. Some of you don't have any good memory. So anyways, in this one, my table has headers. Okay, yes, it has headers. Okay, very good. So I have already my table in there. Remember, we also have to adjust them to the length. Remember, I go here whenever I see that. I double click, and I double click. Okay, this one is slightly longer. I don't like it that much. Why? Because it's adjusting to cost due to traffic congestion. That is the problem with this one. So, well, that one, I'm just going to adjust it because I don't need it to be so long. That doesn't matter. When I want to adjust it, this one I was just demonstrating. So anyways, in this case, we're going to do it that way. We have already that. We have the data in a table. We already did that one. Then we're going to convert the values to USD. This one also, we already did it. One more time, we go select all the data, Control Shift down, and then I'm going to go to the bottom of the money. Okay, then I'm going to click English United States because I want to do it in dollars. Okay, we're going to be talking in dollars, so we're going to focus on dollars. So what's we're going to be working with. Okay, so in this case, I did it. Very good. Adjust the length of the cells to the size of the data. I did it. Summarize the congestion cost for all the cities by finding the average. So in this case also, we have done it before, but then we'll continue to practice one more time. So in this case, we have equals average, and then I just select the range. Good. Now remember, in this case, we have to continue working with money. So we have to not one, sorry. We have to make it English United States. Remember, across we have to use the same format across all the sheet. We cannot do in one with decimals, and the other one with not without decimals, in one with dollars, and the other one with Korean won. No, we have to work straight through all the sheet with the same format of numbers. Okay, so in this case, I found the average. I did it very well. Max value, min value. So in this one's equals min. Remember, minimum number. I need to select the range, and then it goes. Remember, I have to pass it again to English, or I can just select all the. If I can do it in just one shot, I will do all the calculations, and then once I'm done, then I can just transfer them all to USD. It's up to you. You know how you work. Which one is the most efficient? I think it's most efficient to do all the calculations, and then you do the transformation to USD. But in this case, we're gonna do it that way because I am doing step by step. Okay, so very good. So in this case, we have the maximum value also. In this case, I'm gonna do equals max. Okay. Okay, very good. Then we have it there. Then we're gonna put it into USD. Sorry, my predetermined button is already Korean one. So anyways, good. So now we continue working. So in this case, I already done that one. I already the max value and I already found the minimum value. Now let's go to a new function, which is lower quartile and upper quartile. So this one we have learned about quartiles already, but I didn't teach you how to find them by number. I only taught you how to find them with the box plot. So majority of the time we're not going to use the box plot when it comes to business. I mean if we need to look at it graphically, we will do it, but sometimes we just do the calculation very quickly without all that one. So in this case, what I'm going to do is it's equal quartile, and then in this case I go to select my range, and then I put a comma, and then it gives me one option. Well, not one option, it gives me a couple of options. It says I want the first quartile, median value, so I want the 25, the 50, 75 for the maximum value. So in this case, I'm gonna go to the 25 because that's what I choose. Lower quartile and upper quartile. Yeah, that one was a lower quartile, and then the same thing that was quartile. Don't do quartile, XCC, INC, quotient. No, those ones are not needed. Okay. Be careful not to enter. If you enter, it's gonna tell you, oh no, you entered too few arguments for this function. So before you do that, you put comma, and then you're gonna choose which quartile you want. So in this case, I'm gonna go for the third quartile. Be careful, here is mentioned as first quartile and third quartile. We usually know it as lower and upper, but in this case Excel knows it as first and third. Okay, so that's slightly different from what we have learned in class, but pretty much is the same. So this one I didn't put the quartile, sorry. Yeah, there we go. So this one, these two, we have to do it in USD. Okay, we have it. So lower quartile and higher quartile. Okay, very good. And then let's continue to our instructions. In this case, I have the quartiles already done. Then summarize the variation congestions from one city to another using the standard deviation. So let's talk about the standard deviation. Remember, the standard deviation, we want to know what is the average distance of all the numbers from the average. Okay, so in this case, I'm gonna go to the standard deviation in here, and I'm gonna calculate it first, just standard deviation. So I'm gonna go to equals standard deviation. I'm not gonna use a population or the sample, just gonna use the standard deviation. Okay, so in this case, I'm gonna select one more time all the numbers. Okay, and then I have that the standard deviation is 163.42. Okay, that means on average numbers are far away by 163, meaning, right, the average is 434. On average, almost every number, or on average, if I put 163 plus 434, majority of the numbers are gonna be there. If I put 434 and then I put minus 163.42, majority of the numbers are gonna be there. So let me explain it graphically. Okay, so in this case, what I'm gonna do, for example, is I say, for example, one standard deviation means, remember, if the data, remember, in this case, we have the line, if the data is normally distributed. If it's skewed, you cannot do this. Okay, so if it's normally distributed, If it's normally, well, we have here the average, right? Average, okay? One standard deviation, two standard deviations, three standard deviations, and then probably here is four standard deviations, five, etc. Okay, so anyways, if the data is normally distributed, we're gonna find 2/3 of the data within one standard deviation. 2/3 of the data are gonna be in one standard deviation, minus or plus. Okay, so in this case, I'm gonna say 434 plus 163 is here. 434 minus 163 is here. Okay, so that's one standard deviation. And then two standard deviations is the same thing. When I add this number 2 times and when I minus this number 2 times, that means 99% of the data is gonna be there. 99 point, what was 99.1? I can't remember. So in this case, 99% of the data is gonna be within 2 standard deviations, and then maybe one value is gonna be on 3 standard deviations, right? So that's the 1% that is left that is gonna be. So mostly all the data is gonna be there. Okay, so hope you understand that already. Okay, so in this case, like I said, we have one standard deviation, so that means the data is gonna be, this is the average. I'm selecting the data. Why? Because if I change, and let me explain you something very quickly. When I select the cells, in this case cell F6, it doesn't matter what I change in there, this cell is gonna follow that. But if I put the number, if I change it, it's not gonna happen. So in this case, for example, if it's whatever I write on the F6 cell plus whatever I write on the cell F5, add it. Okay, you realize, for example, here I have 597. Now if I were to do, let's look at the difference between the functions of Excel. If I do 404 plus 39 plus 163.42, yeah, it gives me the result. Gives me exactly the same result. But what is the difference? That in business we change a lot the numbers. We need to clean them, we need to change them, there's variances, there's changes. So in this case, if I have this data and I want you to look very, very well at this number, 597.81, they match, right? So because I said on this cell, whatever is on this cell and whatever is on this cell, add it. In this cell, I give him the specific numbers. So what happens if, for example, here I change this number to 0? You realize how everything changes? This change, and this change. But not this one. This one doesn't change because I just added what? The numbers that I said. That one remains to be the same. Okay? 597.81 doesn't change. So this is good because, like I said, when we use cells rather than numbers, then we can change the data, work with it, and then everything will be automatically updated. Okay, let me go back. Okay, this one we have it there, right? So in this case we have this plus this value. Now what I can say, 2 standard deviations. So that means whatever you find in this cell plus this cell, that's 2 standard deviations. Then whatever you find in this cell plus this one is 3 standard deviations. So when we look at this, again, let's look if that's right, what we were saying about whether all the data is there or not. So in this case, I can say Maximum value is 807. Minimum value is 99. Okay, so first look, I mean, the average is 434. Let's look what's above 434. So we look at the numbers. Let me remove that. So in this case, 597. We look at the numbers. Yeah, majority of the numbers are within one standard deviation. Let's see if there's anything within two standard deviations. So anything that is higher than 597, yeah, here there is 638, 610, 671, 641, 651, etc. Okay, so majority of the data is still within two standard deviations. So can we say that also 99% of the data is there? Yeah, but we have that there's a value 807 that is even within three standard deviations. But I mean, like I said, it's 1%. So which one is it? Because there's this number 807. That's already very, very far. No, so that's within three standard deviations, but it's only one. It's only one. So it's the only number that actually is exceeding those three standard deviation on the positive side of the curve. Okay, so that means only this number is doing that. But as I said much earlier, all the data is located within two standard deviations. That tells us that is this data either is approximately normally distributed or normally distributed. Okay, if it's slightly skewed, that's all right. That's not a big issue. It also causes us just slight problems, but not a big issue. Now let's look at the negative side. Okay, when I say so, in this case I have 434. Sorry, I forgot the equals 434 minus 163 to 70, and then I have equals this one minus 163, and that's two standard deviations, and then equals 107 minus 163, three standard deviations. Okay, so actually on that side of the curve, everything it's within two standard deviations. No, because we also have 99. Okay, so technically the same in this side. Majority of the data is within here. To the lower side we have 200 and 250, let me see, 434. Wait, I need to change this. 434, 400 and not 301. It's there within the two, within one standard deviation, and then we go to smaller numbers. So everything is mostly located within this one and this one. Okay, we have one. They also 99. 99 is between 107 and minus 55. Okay, so like I said, we can realize that, for example, from the average plus are most of the numbers are here, and minus here on this side, most of the numbers are within here, minus and the plus. Okay, on that curve, on that normal date. Okay, very good. So now, the lower the variability, the more normal the data distributed it will be. As simple as that. Okay, so in this case, summarize variation. Okay, we already summarized that one. We already add minus the standard deviations. Then it says insert a box plot. Check if the data is normally distributed. If 2/3 of the data are included in one standard deviation, check then if 99% of the time. So this is exactly what we did, but now let's look at it graphically. So in this case, let's insert here. Let's insert. Sorry guys, this is I forgot to select the data. Sorry, we select the data in here. Okay, we select the data and then we put insert, and then we have the box and whisker. Okay, this one, let's pull it. Let's pull it to the top. Okay, let's put it here. That's gonna look nice. Then let's add, right click, we put the data labels. Sorry, data labels. So let's see, majority of the data is located within those numbers that we mentioned before. So within 597, yep, every 556 is below that, and on the other side 270, well, not majority, but it's almost normally distributed in these cases. By 20 numbers is almost there. But if we look at the lower one, on the lower quartile, yes, it's 107. So majority of the data is located within two standard deviations. Yes, majority of the data is located within two standard deviations. There is only some numbers that no, they are not outliers because they are still considered somehow part of the numbers. So in this case, there are no outliers in this case, but that's how we look at it visually. So in this case, like I said, we said the data is normally distributed. 2/3 of the data are included, yes. 99% the data is in two standard deviations, yes. All the data is already within two, right? 761, 761. Let's look at it. 761. Yeah, actually everything is below that on the positive one, and on the negative side we have it two standard deviations, 107. So actually, yeah, also okay, very good. So we can see that all the data is majority. There are just like these cases of 807 and 99 that somehow are not there. Okay, so it's done. Draw a histogram of this data set and check if it's normally distributed. Actually, in this case, we already can see. Remember, if this x touches the line of the median, that means it's normally distributed or very slightly, very slightly skewed. Like I said, that's not a big problem. Slightly skewed is not a big issue because it doesn't distract us that much. So anyways, my instructions, the evil professor is asking us to insert a histogram. I did it again. Sometimes I'm very stupid. I didn't say it. So insert, and this one we go there to the histogram. So in this case, let's put it here. I'm gonna make it smaller to fit it nicely there. This one also I'm gonna make it smaller because I can. Okay, so that we can fit almost everything there. Okay, this one also, let's align them. Let's put them nicely aligned in there so that we look at those graphs in a nicer way. Okay, so now in this case it was asking us to do 5 bins. It automatically gave me 5 bins. So 1, 2, 3, 4, and 5. Okay, so in this case 1, 2, 3, and 5. Do I have them? Is it normally distributed? Yes, it is. Just on. Okay, we have a normal distribution somehow, and majority of the data is there. Okay, we have some like 99 that is a bit far away, and then this one is also the over 761. Okay, well, that's why I say majority of the data is located here. 99, only those 99 and 801 are causing a lot of trouble. Okay, they're good. So now, is this normally distributed? Yes. I'm not gonna write it. Calculate the average and standard deviation on this graph. This one we already have it. Sorry, I think I missed that one. Standard deviation and average is already there. That's already done. Okay, now consider the variability in traffic congestion for northeastern and southwestern cities. In particular, which group shows more variability in congestion from city to city? Explain why. Okay, so in this case, we're going to look at the variability in the northeastern. So what we have to do is let's do a standard deviation of the northeastern cities. And we're going to select the data of the northeastern cities. Okay. And then variability of the southwestern ones. Standard deviation of the southwestern ones. Southwestern cities. Okay, so now in this case, let's put them both in the same format. Okay, so we have in this one the southwestern cities has higher variability. So this is when we start to apply the principles of qualitative and quantitative analysis. So in this case, yes, in quantitative analysis, there's more variance on the southwest, meaning that the distances, sorry, the cost of it can be way higher, way lower from the average, right? It varies, maybe because some locations are very near and some others are very far. So that's why the variability is given, or because the traffic varies in many areas of the city that we wouldn't know, and that is when we will have to turn to qualitative observation. In qualitative observation, we will go to the city and ask, okay, why is in this city happening the more variability? Is it because of the data is taken wrong? Is it because of maybe the layout of the city? Is it why how people drive? Is it the way that maybe the driver's licenses are given and people is slower there? Roads are more congested. I don't know. We have to look at that qualitatively. So here just we can say quantitatively southwestern has more variance, and that's it. Okay, so that's what we're going to be looking at, the difference between the two of them. Okay, so this one, write a paragraph summarizing what you have learned from examining and summarizing this data set. That one I will leave it up to you. What I learned is that I'm not gonna tell you. I already know what I learned. So in this case, your graph should be looking this way, and yeah, you should be done. All right. Now we have hotel room instructions. You have this data. Also, the same thing. You have to fix the data. This one is a much smaller data set. It talks about, for example, hotel room prices, and then this one you're just gonna be looking at the hotel room prices on average per city. No, in this case, every chain they give their cost on every city, every hotel, and that's it. No, so in this case, you're gonna be doing the checklist in this one. Also, data in a table, the lengths, order in alphabetical order. You're gonna be doing some conditional formatting, etc., etc. This one, read it with time and do it on your own. I already help you because I already format these things for you, but um, actually you're very lucky and very nice to you, because in previous semesters I don't do that for anyone. I just let them do whatever they have to do on their own. Okay, so anyway, so this one, do it. If you have any questions, again, contact me through Kakao, which is the fastest way. For those who have Macs, please understand I don't have a Mac, so I have to first figure out what's going on with their Mac, but I think pretty much this you should have all the functions that I'm using in here. Okay, so that should be all right. Okay, thank you so much, and then if you have questions, let me know.